Hello, builders, and welcome to a new episode and a new season of Building SaaS on AWS, the AWS SaaS Factory show for builders of SaaS here on Twitch. My name is Anthony McClure, and I am a solutions architect with the AWS SaaS Factory and your host for today's show. Now, if you are currently a builder of software as a service solutions, or even just getting started in learning how to design, build, deploy, and operate applications in multi-tenant environments, then this is the show for you. As in every episode, we strive to bring in subject matter experts that can dive deep into the many and various topics and aspects of SaaS. And of course, today's show will be no different. Now, before we jump into the content for today's show, I want to extend a warm welcome to all of you that are joining us live here today on Twitch. If you are joining us live, please jump into the chat, say hello, let us know where you're from, and make sure to say hi to Mr. Bill Tarr, who is acting as our moderator for today. Bill can also help with asking or answering any questions that you may have. So please make sure and put your questions into the chat as well. And I will either try to answer them with our guests, or Bill may do so as well as soon as we can. Now, also, if you're joining us live, please make sure to hit that follow button if you like this kind of content that AWS is putting out. And if you are seeing this video later on, video on demand on YouTube, make sure and hit that subscribe button as well. Now, with that out of the way, let's dive into today's content. At the end of last season, we had a show about SaaS and generative AI, specifically focusing on details around data isolation and data protection when dealing with generative AI in SaaS solutions. Today, we want to continue that conversation talking about generative AI, but looking a bit more broadly in how we can design architectures to take generative AI and put them into SaaS solutions. So to help us with that today, I'm going to bring on two guests. Both of them are veterans to the show, as I would like to welcome Mr. Mehran Najafi and Ujjwal Buka, both solutions architects. Welcome to the show again, gentlemen. Mehran, why don't we go ahead and start with you as far as quick introduction is concerned. Introduce yourself, and then we'll bring in Ujjwal.
Thanks, Anthony. Hi, everyone. Good morning, good afternoon. So my name is Mehran Najafi. I'm a senior solution architect with AWS. I'm part of both SaaS community and AI ML community. So I'm very interested in that intersection of building multi-tenant solutions with AI ML, with GenAI, and I'm very happy to be here talking about some patterns that we have seen with customers, and we will have a conversation around them.
Excellent. Welcome, Mehran. Ujjwal, how about you?
Sure. Hi, everyone. My name is Ujjwal Buka. I'm a senior solution architect from AWS SaaS Factory team. My team primarily helps various ISVs and enterprises with their SaaS journey. We provide business and technical guidance through which we try to accelerate their SaaS journey. And then again, I'm happy to be here, and I'll be glad to share some of the content which we prepared for you all. Hopefully, this will be helpful for you all.
Well, again, welcome to both of you. We have an exciting show today. So why don't we go ahead and just jump right on into our topic. So when we're talking about SaaS and generative AI, both very exciting, sets of technologies. When we start to put those together, what are the building blocks that we like to use or can use on AWS to make these two technologies work?
So yeah, I mean, before we talk about the building blocks, let's I would like to just take a step back and just talk about how does the SaaS and generative AI fit together, just to set the context and to set the stage here. So
Absolutely.
Yeah. So when you're building a SaaS solution, or when you're maintaining a SaaS solution, you will try to bring in a new framework or a new feature only to basically to enrich your customer's experience, right? So generative AI feature or generative technology is also no different here. You would bring in the using the generative AI technologies, you could enrich the customer experience, basically provide a targeted enrich experience for your tenants. And then when you bake in your generative AI features into your architecture, you might have to rethink your tiering strategy, because now you have to think how I could better package my this enriched experience for my tenants. So when you it will change your tiering strategy, it will impact your pricing and packaging strategies too. And also, using generative features, you could enrich your operational efficiency of your SaaS architectures. What I mean by that is, like, when you build a robust SaaS architecture, you'll try to capture various tenant aware metrics, so that it will help you to understand how tenants are using your architecture. So using generative AI features, you would be able to analyze those metrics faster, and identify any problems faster, and also it will help you to find a solution faster. And again, in general, you can also use the generative AI features to automate most of your tenant life cycle management, and also optimize your tenant onboarding experiences, so that you provide a better experience for your customers. And in general, you can bring in the generative AI features to enhance your existing SaaS solution feature, or bring in a new feature, which will act as a differentiator for your SaaS product when compared to the other SaaS products out there. So the hopefully it gives a rough idea of how you could combine SaaS and the generative AI together here. And coming back to your question, Anthony, about what would be the building blocks here. Yeah, in generative AI, I'm pretty sure everybody has heard this word of foundation models, or the large language models. That would be the basic building block which you would use. And in order to interact with these large language models, you would use some of the AWS services, like Amazon Bedrock or Amazon SageMaker. Through these services, you'll be able to interact with large language models. And there are a bunch of large language models available on AWS through partners like Cohere and Anthropic, and also Amazon provides a bunch of foundation models there. And in order to interact with those models, as I said, you could use Amazon SageMaker or Amazon Bedrock. And then after on top of that is where you would bring in the multi-tenant angle, and there you could use some of the patterns or mechanisms, or whatever you call that, to customize these foundation models. One, you could fine tune a model to provide a better multi-tenant experience, or you could think about injecting the tenant context. That's where the RAG pattern, or the retrieval augmented generation pattern, comes into the picture. And through these patterns, you try to provide that multi-tenant experience. So to sum it all together, the bottom building block would be the foundation models. You would interact with those models through the Amazon services, and that like Amazon services like Amazon Bedrock or SageMaker. On top of it is where your SaaS application, using your SaaS application, you will use these patterns of RAG pattern, or the fine-tuning pattern, to provide that multi-tenant experience, and you package that or offer that as a features through your SaaS applications. I know I gave a long answer here, but that's how hopefully you got an idea of what would be the different building blocks here.
Right. So as we start thinking about this then, and that's it sounds like it's awfully complicated. There's a lot that goes into that. So Miran, maybe how would we start thinking about, how do we architect this, right? This generative AI experience when we're talking about SaaS.
So, if you want to look at the SaaS, like a GenAI as a service, or a SaaS, which SaaS solution which is enriched with GenAI, really the first or simplest way is looking at that solution as any other SaaS offering. So in any other SaaS offering, we usually have a control plane. The control plane is in charge of onboarding a tenant, monitoring, metering, billing, all those shared services that any SaaS solution needs. So we have those kind of services, right? Like any other SaaS solution. Then we have an application plane. That's where the logic stays. So this is a GenAI solution, right? So as Ojwal mentioned, all these GenAI, they have that kind of brain, that foundation model, that LLM. So somehow we need to see that how that LLM would fit into a picture for a multi-tenant solution. So here we have multi-tenancy. It means that we need that kind of brain, that LLM, to act differently for different tenant, right? So we need to look at how we can make that LLM, that foundation model, tenant specific. So Ojwal mentioned about different way. The first one is probably the simplest one, is that we keep the same one, the same generic LLM for all our tenants, but we make them more specific to that tenant request by prompt engineering. So it means that for every tenant, we send a separate kind of prompt to get a separate set of responses that represent that tenant data. So that's probably the easiest one to implement.
Hmm.
The other one is that, we look at the fine tuning. So we say, okay, I don't want to use the same generic LLM for all the tenant. I want to create one tenant a specific or more tenant a specific LLM for each of my tenant. So now we are dealing with every tenant or a number of tenants. They have their own dedicated LLM. So that is called fine tuning. But the one that's going to be the focus of today's show, and that's what we are seeing mostly used today with the customer, is on RAG. So RAG is for retrieval augmented generation. It means that, we help LLM, we provide tenant a specific content and context for that tenant, for that specific prompt to the same LLM. So we are not going through that fine tuning of the LLM. That's very
Hmm.
costly and not really easy till today. Might be changed next year or in a few months. But now the preference here is to use the same LLM, but retrieve tenant specific data for that tenant, provide it to the LLM, and then LLM will generate the tenant specific responses. So, by looking at your SaaS, which has LLM, which has GenAI, looking at it, okay, I have a control plane. That's going to be very similar to other type of SaaS applications, but I have an application plane. I really need to think about that piece, that LLM, how I can make that one specific to my tenants.
I would say also there's probably, it's really going to be some combination of those different things, right? With prompt engineering, RAG retrieval, maybe fine tuning on a customer by customer or an organization by organization basis, which of those they would end up using. Is that correct?
Yeah, no, that's a very good question. And usually, when we talk to the customer, when we go through those options, very natural, quick question comes up is that which one should we use, right? So these are the options. And what we see here and what we recommend here is that, always start with the easiest one. So that's prompt engineering. Then go through the RAG. And then when you are mature, you see that how you can provide a tenant a specific content to that LLM, to that generic LLM, then see that, okay, how can I use fine tuning? But using
Mhm.
fine tuning, you are saving on the prompt, right? So it means that your LLM is trained, is fine tuned based on each tenant data. Then you have a tenant specific LLM. So you really
Mhm.
don't need to remind LLM every time about the tenant specific context, right? LLM already know that. So, but it really depends on the maturity of the solution. And then there are some cost implications, isolation. I'm sure we will talk about those factors as well. But for today, we're gonna focus more on RAG, and hopefully you will invite us again to your show, and then we will talk about the fine tuning.
Excellent, of course, always welcome. So why don't we go ahead then and just dive into that? Let's take a look and see what a RAG pattern would look like from a multi-tenant perspective. I know
Sure.
the
Let me
audience
bring
is
my
probably excited. Yeah.
yeah. I'm excited to show you. First, let's look at what would be really those. You started asking Ojwal about the building block. So when we go to each of these approaches, they have their own building blocks. So there are different variations. So what I show here is, so first let's think about, like, if you want to build a RAG, retrieval augmented generation, for one tenant, and you really want to manage everything yourself. So what are the
Mm.
building blocks here? So you need to have a LLM. I will show you shortly. But Amazon offer Amazon Bedrock, which simply you can think of like LLM gateway. So it opens up your access to a number of market leading LLM, so you can connect with them. So that you need to have a LLM. So you need to have a vector database to store your content, your tenant a specific content. So here, for example, I put the Amazon Open Search. So how you store the tenant content in your OpenSearch, in your vector database, you need to have an embedding. We usually use LLM for also embedding. So we need to have tenant-specific data. You store them in S3 or any other storage. You need to leverage LLM. Now here in AWS world, we are using Bedrock. That Bedrock can go to the Anthropic cloud, can go to Cohere, to Llama, and we have a broad range of LLM selections. So we leverage Bedrock to create a vector and vectorizing the tenant-specific data, store them into an Amazon OpenSearch that has the embedding plus metadata, and then that's more on the ingestion of the data. And then when a tenant a specific prompt comes, like for tenant one, so what happens here? We leverage Bedrock to embed and create a vectorization or representation of that prompt. Then it go to the OpenSearch to find the relevant content to that prompt, extract them, and then we add them, we enrich the prompt with that tenant specific data. Again, send them to the Amazon Bedrock, and that goes to LLM, another Amazon Bedrock endpoint, and get the response that is relevant to the tenant and return it to the tenant. So this is how you would build a RAG solution for one tenant if you really want to put those building blocks together yourself. But at AWS, as your cloud platform, our job is to make it easier for you, right? We really want to do all this heavy lifting for you, make it as a managed solution that you really don't have to build this yourself. So easily you just put this together. You just select your option. Do I want which LLM I want to use here, which storage, which vector database I want to use here. So this is called Amazon Bedrock Knowledge Base. So basically everything here you see, and I will show you quickly on the console, you will set it up, and then on the background, this is how it's going to work. So we will build it for one tenant, then we can replicate it for other tenants in different fashion, and then magically it works. So it provides you some level of isolation. It helps you with the cost tracking, uh, with scaling. And for you, the only thing here is to gather tenant specific data. Just make sure you have the tenant specific data, put them somewhere, connect them to the Bedrock knowledge base, and then start like playing with the prompt and see which prompt represent your specific application. And the rest you don't need to worry about it. It's gonna work like a magic.
So we do have a question that came in from chat, Miran, and the question is why do we need two LLMs here? And we're not actually looking at two LLMs, right? The vector database is not a large language model. It's the storage location for where the tenant's IP, the tenant's documents, the things that we want the LLM to work against go into. Is that correct?
Yeah, exactly. So, we use LLM for two purposes. One is for doing the embedding and storing that content into a vector database. And then that vector database provides us some similarity search. So when a prompt comes, so that prompt, we use the same embedding. We create a vector representation of that prompt. That go to the vector database. Vector database provide a similarity search. It extract those chunk of data which are very relevant to that prompt, right? That's the first usage of LLM, to create a vector representation of the content and of the prompt. Then the second use of LLM would be to look at all this data together, the prompt, the question that relevant to that tenant, plus that chunk, that relevant chunk as a text, and then then like a chat, just come up with the answer. So do we use the same LLM for these two? No. What we need to use here is the same LLM for embedding into the vector database of the content and embedding of the question to come up to get that relevant chunk. But then the second embedding could be different. That could be a Amazon Titan, could be a cloud, or any other LLM. So just look at it. But the beauty of Bedrock here is make it very simple. So we just need to point it to different LLM, and it's gonna work.
Just to add here, maybe the first the Amazon Bedrock icon what you see is what it is a knowledge base. It's not an LLM. So it's one of the construct or the feature provided by the Bedrock. So that's a knowledge base. And the second Amazon Bedrock icon, what you see there is the LLM Titan embedding models. So one is the knowledge base and the other one is the LLM. So just want to straight out. It's not two different LLMs. It's just a knowledge base and an LLM.
Thank you very much for answering that, Ujjwal and Menon. And thank you for the question, Dazadjikov. Thank you so much.
Okay, now might be Anthony's the time to look into the code, go to the console, and then see that, probably it make more sense as we are looking at this, how we can build something like this.
Yeah, fantastic.
Okay, so, I just log in into my AWS console. So I'm going to search and I'm going to select Amazon Bedrock. And might be some of you is the first time you are looking at Amazon Bedrock. So as I said, it is like a gateway to the LLM world. So even if you want to play with some LLM, you want to have a chat, so there is a playground here. What it does, as I said, it basically it provides you API, a number of API that you can invoke different LLM. So you can see a number of them here, from different providers. Amazon itself, cloud, like from Anthropic, Cohere, Mistral, Llama from Facebook, and yesterday I think was that Llama 3.1 released, that is now the leader in the open source LLM. Very comparable performance to the cloud source LLM. So as you see, every day there are innovations in this space, new LLM emerge, and Amazon bringing the best of them for you. And really the best thing here, you can use the same API to call them. You just need to pass different ID, if you want to switch between Llama and Cohere, for cloud, you just send a different ID, the different model ID. So that's how Bedrock works. But it's not just this. So Bedrock provides you a number of managed solutions similar to that knowledge base that I showed you. And really the purpose here is to provide you low code, no code approach to building GenAI solution. Now let's look at the knowledge base. If you want to build that kind of RAG experience per tenant, now see, let me walk you through how you can build that, that architecture, this one, right? Using a few clicks on Amazon Bedrock. Okay, so the first one, click on create knowledge base. I'm giving it a name for demo. You can provide some descriptions, set up some permissions, because the Bedrock need to talk to the other AWS services. Now it's asking me, choosing my data source. So my data source, that's where I store that tenant specific content. Could be S3, could be on web. You can ask Bedrock knowledge base to crawl some website. Or third party, like a Confluence, Salesforce, SharePoint. And these connectors are growing. We will see different one coming here on a regular basis. So for the sake of this demo, let's look at, let's assume that we want to put the tenant data into the S3. So next one, I need to set up my data source, giving it a name, then I will browse. So let's go to, I have created one for tenant one. And, the demo I'm building here is very simply, I assume that our solution or SaaS solution is in the domain of providing some financial analysis to our customer. Let's say one customer is interested to know more about how Amazon stock and how Amazon company is performing, and the other one is interested to know about Apple. So I downloaded, I extracted. Let's see if I have them here. So two financial report. This is from Apple that you can download them online, is publicly available, and a similar one for Amazon. So I put them into the S3. So one for Amazon in the tenant one, and the other financial report for 2023 for Apple in tenant two. So each tenant has its own dedicated storage. So this is my tenant one. So and I'm creating one knowledge base per tenant. So that knowledge base really will represent the information for tenant one, and there is going to be another one for tenant two. So very simply, you saw it. So I just connected to my tenant one storage. So another, yeah, go
So
ahead.
at this point in time, we really just have an S3 bucket per tenant, and then we're setting up this knowledge base or setting up a knowledge base for one of those tenants. Is that correct?
Exactly. Yes. And we can. I'm showing you on the console, but all of these they have API, so you can implement them as part of your solution. But this is more, as easier to track. So one more thing I want to highlight here is that it seems simple, but it also has a depth. Like chunking, if you are familiar with RAG, I mentioned that for every prompt you need to retrieve the relevant chunk of data. So that chunking could be a very important part of the solution. So Bedrock give you different options. So you can leverage the default chunking, that when you have, let's say, thousands of documents into your S3, into your storage, how that data need to be chunked. Are you going to chunk it per paragraph, per page, per two sentences, semantically? So all this, so you have options here to set that strategy. So it could go very deep. Even you can add them with Lambda, that you have your own custom logic for chunking your data. So it could be simple, and it could be enable you to build very complex and advanced logic if your application and your solution needs. For this
But that's
demo,
great. But that's great that it's out of the box that those options are available.
exactly. And just really the mindset here is that those parts that you really, it's not relevant, it's not really specific to your solution, your application. Amazon provide them with you with the best practices, everything. You really don't need to worry about them. Hopefully that would work for 95% of the case. But even for 5%, if you have a solution that's very, very specific to your use case, you have some customization, and still those customization options available to you. So you still can use these managed solutions.
Nice.
So yeah, so for now, let's go with the default chunking. Now, and that's relevant to that question, what are the LLM role here? First, we need to specify embedding model. It gives you option. This is for creating a vector representation of the data, of that data that are stored into the S3. So I'm selecting like a Titan embedding version 2, the vector dimension like 1024. So then where we store them, right? Where we store those vector representation, it gives us option again. We can use OpenSearch, or we have another one we already created on Aurora, Pinecone, which is a third party, MongoDB, Redis. So there are options here. And then even for production, you can add redundancy, encryption, so to make it really production ready. So I'm creating OpenSearch. It gives me some review, and then I can click create. So what's happening here? It's building this architecture for me behind the scene, right? And then when it is ready, then we need to sync them. But as I showed you, it's just click, 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 right? So it was no coding involved. So then,
that's fantastic.
when this is ready, then we need to sync. So that sync could take time because there are the data that need to be vectorized and then need to be stored. For the
That's
shape,
where we go out and do the web crawling, or go to the S3 bucket and actually get the data and put it into vector format.
exactly. And you can set it up that every time that there is a new data ingested there, that's
adds
repeated,
to
that adds, and that just looking at the incremental data.
Nice.
So I don't want to keep you waited here. So it usually takes like a couple of minutes to create that knowledge base. Then the next step is to sync the data. Last night I did this. So let me show you here.
Well, that's coming up. I also have a quick question from
Sure.
Tabby Ward. Says, what if customer data is in a relational database? It's not S3. So do you recommend creating a knowledge base and reading and doing that embedding yourself? Or
So
is this really just best for unstructured data? I guess the question.
So it like when we look at this knowledge base, it give you some when let's look at this again. So it give you some option. For now, it support S3 web crawler and this third party. If you want to use knowledge base for now. But for now, these are the options that you can do it, or you can build a custom and then inject the data here. But that's only one way of building like a RAG on AWS using the Bedrock knowledge base. You still can use the Bedrock as a LLM and then connect it to your relational databases, or you can use Amazon Q. So might be in another show we can talk about it. But yeah, these are the options for now. But
Thank you, Miran, and thank you, Tabby, for your question.
okay. So I know Ujwal has lots to share as well. So let me just at the end, I showed you, I synced, I created one for tenant one knowledge base for tenant two. So, when I go to the tenant one, I want to test it using the console. So tenant one, if you remember, was relevant to Amazon. So I put the Amazon financial data into that S3, then I sync my knowledge base. So now let's test my knowledge base. So I can select a model. That's the LLM I want to use. So let's stay with like a Heiko, which is a good or Sonnet, which is a good one from Cloud 3. Then I can start asking a question. So let's ask, how is the finance? How is the revenue, or how was the revenue trending for Amazon in 2023? So this question is going to that knowledge base that has, the Amazon information. I know it's coming back. Amazon revenue showed a strong growth in 2023. That's the growth went 12%. But let me ask about that. That's another tenant. Like we really want to make sure that it doesn't have access to the tenant
the Apple data. Yeah,
exactly. So if I copy, the same question, for example, and then I ask about the Apple. So, hopefully we don't want this to generate any data for us because it shouldn't have access, right? And, sorry, I'm not unable to assist you with this request. So if I go to the tenant 2 knowledge base, here you even can change the LLM, to change the configuration. And if I ask the question here, for Apple,
now we should get data.
so hopefully, yeah, we should get some analysis because it has access to Apple report, right? And just for the to make sure, if I ask this question for Amazon, so it shouldn't give me answer, right? Because it shouldn't have access to like Amazon report.
Nice. So all of that's fantastic, Miran. This is really interesting that entire architecture that you showed in the original slide there is pretty much built out just utilizing the tooling that Bedrock and Bedrock knowledge bases brings to us, which is great. Now, if we're thinking about this though from a SaaS perspective, and we're bringing in new tenants or building tenants on the fly, one of the things, of course, that we recommend as a best practice is that we try to automate or work through that onboarding workflow of tenants in an automated fashion. So if we're talking about onboarding tenants or bringing tenants in to utilize this capability, what does that look like?
No, very good question. And now we go from that fancy word of testing and POC to okay, if we want to really productionize this, right? So we talk about the control plane and application plane. The control plane is those shared services, including the tenant onboarding and tenant provisioning. Let's imagine in my scenario, so you want to onboard a new tenant 3, for example. So we need to do registration. So tenant providing some information about their account or whatever. Then our control plane need to provision some resources, right? Some resources for that specific tenant. I showed you, for like a knowledge base has a vector database, has some connection to the Bedrock, and could have some relational databases, whatever. So that's where we have this tenant provisioning. So for every tenant registration, we need to go through the tenant provisioning. Now it comes with options like any other SaaS configuration. The really first question that comes to your mind here is that, do I need to give a like silo dedicated resources to my tenant, or no, I want to be more leveraging shared resources to be more cost aware and those things, and I go with the pool model. So both of them are supported here. For silo model, it's more what I showed you. So you can have a dedicated S3 bucket for your tenant. You can have a dedicated OpenSearch serverless or OpenSearch service for your tenant. You can have a dedicated knowledge base, and if you need some Lambda function, some compute, so you can have a dedicated one for your tenant. Or if you are more into the shared mode, you have thousands of customers, and some of your customers are very small. It doesn't make sense to give them a dedicated resource. We look at the pool model. So instead of giving them a dedicated bucket, we give them a dedicated prefix. OpenSearch, we're leveraging the same OpenSearch, but giving them different indexes. Knowledge base, it still makes sense that you give dedicated knowledge base to each tenant. But if you are running onto the limits, so that we can even using the same knowledge base, but leveraging some filtering and metadata to make those content different for those knowledge base acted differently for every tenant. And so both of them are supported, and it really depends on your SaaS solution to see which one works best for your use case.
Makes sense there. Oh, that's fascinating. So if we're taking a look then here, let's start maybe from the pool standpoint. How would we then isolate or enforce the isolation between tenants in a pooled scenario?
Sure, I can take that question. Mehran has been explaining it patiently for a long year. So yeah, to explain that, let me share my screen quickly here. Yeah. So I know you're still seeing the same slide, but I just wanted to set some context here. Let's look at the pool model first. In the pool model, what we are trying to do here is we're creating let's take an example of tenant 2 here. For the tenant 2, we created a knowledge base. And for that knowledge base, what you would do is you connect you to a shared S3 bucket. Since it is a pool model, we are sharing S3 bucket. Within the shared S3 bucket, you are creating a prefix per tenant. That's what I'm trying to show here in this tenant tour. And the knowledge base is now connected to that prefix of that tenant 2 to pull the data from that. And then it will push the data to a shared pooled OpenSearch serverless service. So again, here we are sharing a OpenSearch service collection. Within that collection, we create an index for each tenant. So now tenant 2 knowledge base is configured to pull the data from shared S3 bucket prefix of that particular tenant into the shared OpenSearch serverless service collection, in which where we have created index per that particular tenant. So that would be the ingestion story, and then I'll show you in a bit how you would enforce that isolation there using IAM roles here. And then the other part of it is for the retrieval. Let's say we are again using a pooled compute, and this pooled compute, I'll show you how you could use IAM roles and make sure that in a runtime, how can you call the tenant specific knowledge base. So there are two things to summarize: one for the ingestion story and one for the retrieval story. Yeah. So let me jump into the console here to show that how we could enforce. So yeah. So if you see, this is again going back to the Bedrock. Within the Bedrock, I could see that I've created knowledge bases for a couple of tenants. Tenant 1, I used a silo model, and then for tenant 2, we used a pool model. A tenant 3 is pool model. So if you look at tenant 2 knowledge base, for that knowledge base, we have attached a service role. If you look at the service role is KB role tenant to a pool. If I open up this service role, I've already opened up here. And if you look at the policy of this service role, let's look at that policy of this service role. Let's scroll all the way down here. So if you see here, what we are giving permissions is for the S3 bucket permissions to pull the data only from this S3 pooled S3 bucket from this prefix. And again, yeah, and also for the list of the contents also, you're doing the same thing. So what you could see here is I created a service role which is attached to this tenant to knowledge base, which is only giving permissions to pull the data from that S3 bucket prefix. And if you scroll up a little bit here, and here there is another permission which is giving the permissions to this knowledge base to push the data to the collection. It's not the permissions is at the collection level for this policy. Hold on to that thought. I will show you how you could enforce that isolation to the index level. But here you are only enforcing until at the collection level. And the other permission, what you see is this is the permissions to invoke a large language model, that is Titan model. It's basically we're giving permissions for the knowledge base to do that generation of the embeddings. Using this LLM model. Now, as I said, the knowledge base now configured to pull the data from S3 bucket and push the data at the collection level. Now let's switch the gears and go to the OpenSet serverless and look at how we could enforce some of the permissions to only push the data or pull the data into the tenant specific index. So if I jump onto the OpenSet service collection, again, this is nothing but in AWS service, it's OpenSet service. Within that OpenSet service, I've created a bunch of collections. For the pooled model, I'm using a single collection shared across multiple tenants. So this is the pool collection which I've already created. Within this collection, for the pooled tenant, we are creating a pool index. A tenant index for that particular tenant. So if I scroll down here, within the OpenSet service, for the collection, you can create a policy. It's called data access policy. Think that as a resource policy for a particular service where you could restrict the access for the requests coming in. So if I open up this policy here quickly, so what you have is, if I scroll down here, within this data access policy, I've created a rule that what does this rule does is it's basically giving this permissions to this Bedrock service role, which we have just seen, to only access that or push the data, pull the data from the index. The index name is tenant2 pool index within the pooled collection. So if you try to paint the picture here, for the Bedrock, Amazon Bedrock's knowledge base, you have a service role. To that service role, we are giving permission to pull the data from S3 bucket and to push the data into the collection level. And when you look at the collection, that is OpenSet serverless collection, there you're defining a data access policy, which is nothing but a resource policy, which is enforcing to only allowing that knowledge base to push and pull the data to the tenant specific index. That's how you're kind of enforcing isolation for the ingestion piece.
That makes sense. So I can see here then that it's the division that's happening between the ingestion and the retrieval. But it's nice that it's all being handled either by IAM role or service role policies.
Right. Yeah, exactly. And again, this level of flexibility depends upon the type of vector store you're choosing, and other vector stores you might have to do. The concept might be similar, but you might have to do in a little bit different way. But the other piece of the puzzle here is like the retrieval. As I showed in the slide, for the retrieval, we are using a shared compute. So let me give an example of how we would implement that. So for that, to showcase that, I'll show you some of the code here. What you are seeing is a Jupyter notebook. Assume that this is the Jupyter notebook, which is a compute which is shared across multiple tenants. So here, what you would do is, if I scroll back to okay. So now here, let's assume that this is shared compute, and I'm trying to call this knowledge base. So the way what the code snippet, what you're seeing is obviously to invoke that knowledge base, you have seen we are creating a knowledge base for each tenant. We need the knowledge base ID. So assume that I'm hard coding this knowledge base ID for tenant 2 here. But assume that this knowledge base ID information is coming from a JWT token. As you see, if you're familiar with our content, we always say that
getting tenant context, right?
It's basically get the tenant context from JWT token. You assume that you're getting this JWT token, and from that you're getting this tenant context. And using the tenant context, before we passing that knowledge base information to retrieve the data, what we can do is in runtime you can generate a scoped credentials, which would give access to that particular tenant. The way you would generate the scope credentials, I'll show you that in a bit here. So you can see that I'm calling a get temporary credentials method. And if you look at that method, what it is doing is it's first getting an IAM role and then assuming that role. Now let's quickly look at what that role has. If I scroll up a little bit here, this is the IAM role which I'm using, which has these permissions. And you can see the actions is retrieve. Basically we are allowing permissions to retrieve the data from the knowledge base. And at the resource level, I would highlight this piece here. What you see here is a placeholder for the knowledge base ID. This this role usually called as attribute-based access control role, or a back role, or a back policy. So what's happening now is this get temporary credentials method is taking that role, and also we are sending in the knowledge base ID which we got from the JWT token. And the method here, assume role, what it is doing is it's basically assuming the role and injecting this knowledge base into that role, so that you get an IAM policy which gives permissions only to the tenant specific,
only to that one
particular knowledge base. And then it returns you the scope credentials. When I say scope credentials, it's nothing but in the terminology of it's just an access code, access key ID, and secret access key, and the session token. And then this method gets the scope credentials, and then I'm passing those scope credentials to the retrieve data method, which is basically making an API call to their downstream knowledge base to pull the data. So to test this, what I did is I onboarded a couple tenants, tenant 2 and tenant 3. And tenant 2, I'm again leveraging the Amazon's shareholder data, where I ingested and created a knowledge base with Amazon shareholder data.
Same thing that we saw earlier with Medon's example.
And then for tenant 3, I'm using Apple shareholder data. So let's try to run this experiment, saying that hey, I'm able to pull the data from these two knowledge bases, and then I'll show that how I'm enforcing tenant isolation here. So let's first let's pass the tenant to knowledge base, and if I run this query, the query or the prompt which I'm asking is what is this company and what does this document talks about? And a simple thing, I didn't want to go fancy or anything like that. If I execute that, it's running here, and at this point of time, it's basically generating the scope credentials and hitting that knowledge base. And you can see that it says that this document is for the Amazon.com and blah 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 and everything. And if I switch back to the other tenant here, let me hard code here. Let me comment this one, and then now here I'm using the knowledge base of tenant 3. And again, I'm hard coding this one, but ideally you would get this from your JWT token. And if I execute this, it should pull the data from the Apple and mention that this is a shareholder data or the document from Apple, and so on and so forth. So you can see that this document is from Apple, and it talks about all those things. So now let's show that how we are enforcing tenant isolation. We talked about concept here. So let's say now I'm using the knowledge base ID of tenant 2, and then getting the scope credentials of tenant 2 and passing those script credentials to the tenant 2. But for some reason, it may be a hack or a typo or error. I kind of when I'm passing that knowledge base ID to retrieval method, I'm kind of hard coding it to tenant 3. So basically, what I'm trying to do is I get the scope credentials of one tenant, but somehow mistakenly or due for the hack or something, I'm injecting the tenant 3's knowledge base ID. And if I execute this one, let's see what you get. So you can see that you're getting access denied here. So even though you're sharing this compute or this Jupyter notebook in this case across multiple tenants, in runtime you're generating the scope credentials of that tenant and enforcing tenant isolation. So that's how you can enforce tenant isolation in here.
So these are very similar concepts to what we talk about in other aspects of enforcing tenant isolation, right? There's really nothing new here. It's still that ABAC way of doing things, but it's great to see that this interacts very well and syncs very well with generative AI capabilities as well. We are running up close to time here, and I know that we have still a lot to cover. Ujjwal, could you talk just briefly maybe about what a differences would look like in a silo model compared to the pooled model?
So if let me use the slide here, coming back to the slides here. So we just saw about the pool model. So in the pool model, as to explain here, what we are trying to do is when you're onboarding a tenant, as I mentioned earlier, so you have a shared S3 bucket and a shared OpenSets serverless service. But within that one, as I showed, we are kind of creating the constructs which are shared across multiple tenants. To back up a little bit here, what you're doing when you're onboard a tenant, for the pooled tenant, tenant 2 or tenant 3, we are creating a knowledge base which is tied up to the prefix of that shared S3 bucket. And then it is again tied up to the OpenSearch service index, where we are creating index per each of those tenants even though the OpenSearch serverless collection is shared across multiple tenants. And the compute is basically shared, and you can again use the shared compute to interact with these particular tenants. That's how you could implement the pool model. Whereas the other end of the angle is a silo model, where in the silo model, what you can do is like you can create a separate S3 bucket, separate OpenSearch serverless collection for that particular tenant, and then obviously you will create a knowledge base for that particular tenant. Now, in this case, the knowledge base is tied directly to the S3 bucket, which is again dedicated for that particular tenant. And then you can also attach that knowledge base to the dedicated OpenSearch serverless collection. And then you can have a silo compute, which are interacting with this knowledge base. And in a silo model, again, since everything is dedicated, the way you could enforce isolation, again, the same way. For the ingestion piece, the knowledge base has an execution role, service role. That service role will give permissions only to pull the data from that S3 bucket and to push the data into that dedicated OpenSearch serverless collection. And for the siloed compute, for the retrieval case, the siloed compute can have some kind of an execution role. This compute can be EC2 instance or the Lambda, and you can attach this execution role, and that execution role will give permissions only to interact with the dedicated knowledge base of that particular tenant, as I'm showing here in the tenant one. Hopefully it makes a clear picture of how you could, in a silo model, you are using all the dedicated resources, whereas in the pool model, you're sharing the S3 bucket, we're creating separate prefixes, and you're sharing the OpenSearch serverless collection, where we are creating index per each of those tenants and sharing the compute, and you're enforcing isolation.
Excellent. Now, one other question that we have, trying to get here before we end, is related to Bedrock agents. I know that's been talked about quite a bit as well, some new capability there. What would that look like if we were to try and use that? Or can it even be used, for that matter, in this sort of architecture?
Sure. Yeah, definitely. I mean, whenever we're talking about knowledge base, the agent word always comes in. Yes, definitely we can use the agent. So just to step back a little bit, we're running out of time here, but I'll try to briefly introduce that concept, and we'll maybe in the next episode we can go deeper into it. So think of the agents in a simple terms. I'll try to explain. Think of an agent is a piece of code which can sit next to the LLM, and it can interact with LLM to get that brain of it, to make some decisions. So you could create, and I can quickly show a piece of code of how you can define an agent without going much into the details here. So when you are creating an agent, in this example here, so what you do is I'm showing you is how you can piece of code, how you can create an agent. And what I'm showing you is an agent which can do a e-commerce agent, which can create some products and order services. What you do is when you're creating this agent, you set some instructions saying that, hey, you are an agent, we will help with these things. What are those things? Create products, get products, and create orders, and so on and so forth. And then you define that agent here using this, the API calls. And in there, and obviously I've given the instruction, so there should be a piece of code which should execute these instructions, right? Those piece of code would be get products, create products, and everything. So that piece of code can be configured to run in a Lambda functions, and then you can attach that Lambda function to this agent. So let's say you've created this agent with this agent ID and everything. There is another construct, what we call that is an action groups, and it's basically, think of this as just a setup where you create this action group. In this action group, you are attaching that Lambda function. That Lambda function has all the methods of that instructions which you defined there. And the other angle to it is obviously, for the agents to run or interact with AWS services and everything, you need to have some kind of an IAM role or anything should be attached to it. So it's pretty straightforward. In fact, you attach an IAM role. So think this is an agent which runs a piece of code which sits next to the LLM, and that piece of code runs within the Lambda function to which we are attaching an IAM role. And then if you look at those methods, would be bare bone methods saying that a create order, create product, and everything. And when a request comes in, the way you would hand out that request is in a multi-tenant environment, you have these microservices. In those microservices, you get, let's assume that you got a request to create a order for a particular tenant. And then within your application services, you could send that request to this agent. In order to send that request to the agent, you use another API call called invoke method. Through the invoke method, you hand out that request to that agent, and the agent takes the request and talks to the LLM and understands, okay, the user has asked me to create an order. So then it says, in order to create an order, I need the product ID. It's not been provided. So it interacts with LLM and makes the decision and prompts you back the request saying that, hey, you're asking me to create a order, but I don't have the product ID. Can you provide the product details? And then it gets that brain of going through a back and forth, and
almost like a chatbot sort of situation built up there.
Yeah. And then I know I'm trying to squeeze in a lot more here, but the agent can. Yeah, sorry.
No, go ahead, finish your thought.
Yeah. So the agent can also be used in a multi-tenant environment, and you can enforce isolation and all that good stuff. So you can see that when you're creating the agent, we are attaching an IAM role to it, and using that IAM role, you could create a silo agent where we are empowering the agent to only interact with the siloed resources of that particular tenant. Or for the pool model, again, what you could do is like when you're attaching an execution role to the agent, you won't give any permissions to it, but when application service, when is invoking the agent, can get the scope credentials the way we have talked about earlier, and pass those scope credentials. And then can pass the scope credentials. Like for example, to show you quickly, here is that I have this agent. Think about a agent for tenant 3. I get the tenant context and generating the scope credentials. Again, those scope credentials uses the same concept of ABAC and everything, and then you can pass those scope credentials when you're invoking the agent. Now, within the agent code, the Lambda code, you can take these credentials and enforce.
Only has the access based on those credentials, right?
And it can interact with those any AWS services. It can be a knowledge base or a DynamoDB table and everything. So yeah, the agent which I'm showing you the code here, kind of like uses scope credentials to interact with the DynamoDB table to create product and order service.
Very cool.
Yeah.
Well, that's fantastic. I know we have so much more that we could cover here. Obviously, we could go deep into agents and SaaS. We could go into fine tuning and SaaS. In fact, we're planning on having Ujjwal and Miran back on to talk about fine tuning specifically in a future show as well. Of course, time flies when we're having fun, gentlemen, and this has been a great show. Very interesting content. I want to thank you both for being with us today. Looking forward to seeing you on our next show. For those of you that are joining in the audience and stuck with us, thank you for being here as well. Make sure and come back and see us in a couple of weeks where we're going to be having a new episode again of Building SaaS on AWS. We'll be talking about VPC Lattice, newer ways to network your SaaS applications together. Until then, though, I want to wish everybody happy building out there.